In this section of the course, we're going to talk about computer ports. And no, I'm not talking about those physical ports such as your USB ports, your HDMI ports, and your FireWire ports on your computer. I'm not talking about any of those physical ports. I'm talking about logical ports that are assigned to the operating system by the computer to manage network connections. So let's go ahead and get into it. So why do we need these logical networking ports? Well, computers require networking ports because network applications are abound on operating systems. So for example, you could be on your system, you could have Outlook open, you could have Internet Explorer open, and you could have FTP open. Well, they all want to communicate with your IP address across the network to another device. But you only have one IP address, so how does your computer identify what application that it's communicating with and what protocols it's communicating with? Well, it uses ports to associate packets of information with TCP/IP protocols such as HTTP, POP3, SMTP, and so forth. And so what happens is that we have our networking services. They're assigned with a specific port number. So for example, DNS has a specific port number that it's assigned to. HTTP has a different port number that it's assigned to. SMTP, the same thing, and so on and so on. So that's why we need ports. And if we didn't have ports, then there would be no way for you to be multitasking because you only have one IP address and you only have one MAC address on your computer. And so we need these ports to differentiate what network protocols and services we're communicating with. And so, for example, if you wanted to browse the internet, you would use HTTP TCP port 80. If you wanted to send and receive emails, you would use SMTP TCP port 25 and POP3 TCP port 110. Now, another thing to really concern yourself with is that firewalls, when we're talking about our network security, is that, remember, if we are differentiating what we're doing by port numbers, firewalls filter network traffic by port numbers. So for example, let's say that you didn't want people to browse the internet outside of your network. You could block TCP port 80 on your firewall and nobody could access the internet to do any browsing. Or same thing for emails. If you didn't want your company sending any emails in or out of the network, maybe you are a secure network and you have proprietary information, well, you could block TCP port 25 and TCP port 110 to block SMTP and POP3 on your firewall. So that's one thing, just a quick introduction to firewalls. Now, when we're talking about ports, there's a lot of ports available. For TCP IP, there's a total of over 65,000 ports, and there's some well-defined ports. So let's talk about those right now. So there's approximately 65,000 ports available. However, for these protocols that we talked about in the previous section of the course, all these different TCP/IP protocols that we talked about, well, for all of those, there are assigned port numbers, and what we do is we call these well-known port numbers. So we have ports reserved for those, and anything under the number of 1024, it's going to be pre-assigned. Now let's go ahead and let's take a look at these actual port numbers. So here's a table of our well-known ports, and these are the protocols that we talked about. We have a majority of all of them in here. We have our file transfer protocol, we have our secure shell protocol, our telnet, our simple mail transfer protocol, our domain name system protocol, our trivial file transfer protocol, our HTTP protocol, our POP3 protocol, our IMAP4 protocol, and lastly our HTTPS protocol. So you'll notice that for these protocols, there's the protocol name, there's a port number assigned to them, and then the port's going to be TCP or UDP. So a port can either be UDP or it can be TCP. And so if something is port number 20 on TCP, that's going to be different than port number 20 on UDP. And so what I want you to get out of this is you don't have to memorize these because this is just an introductory course. But for those of you that do want to do a certification future on in your career, then you're going to have to memorize these well-known ports. And it's important to understand that, for example, DNS operates on port 53 for UDP, and HTTP operates on port 80 for TCP, and Telnet operates on port 23 for TCP, and so forth. So you're going to get quizzed on those when you take those certification exams. So I know this may be a bit foreign to you, but hopefully this next slide is going to help it make a bit more sense. What we're going to do here is we're going to go over ports in action. So I'm going to go through the process of how this works. So how does this work? Well, let's assume this is you and you're on your laptop and you just have a random IP address assigned to you of 192.168.1.112, and let's say you want to browse the internet. Let's say that you want to browse a certain web server, and so we have this web server over here, and its IP address is 110.90.45.96. Well, we know the source and we know the destination IP address to go back and forth and communicate, but now we have to differentiate, and we need to tell this web server that we want to communicate with it by sending requests to specific port numbers. So how does it work? Well, step one, your computer is going to initialize a random high port number on its system to be able to communicate back and forth. So for example, your system is going to initialize this random port number here. So what it does is your operating system is going to assign this port number a random high port number for this session, for this communication, with you having, for example, Internet Explorer open. And you type in that web address. Let's just say it's my website, microgrinder.com, and you want to communicate with this web server. Well, you're going to send specific information. If you need to find out what the IP address is, then you're going to send a request for DNS to convert that domain name into an IP address to get that. So you're going to send a UDP request to port 53 to find out what the IP address is. Now, if you already have that in your table on your system, on your ARP table, then you don't need that. If you already know the IP address, then what you're going to do is, for example, if you want to communicate over just standard HTTP, and my website doesn't have any encryption in it, then you would send a request for TCP port 80 to get information off that website. Maybe you're sending a request just for it to load the home page. So you'll send a request to the IP address of 110.90.45.6 on port 80 TCP to have them send you the home page of that website, and it's going to go ahead and it's going to be listening in on these ports. So the web server is going to be listening, for example, on this instance on port 80 for that HTTP request, and it's going to receive it from you. It's going to say, okay, well, I know to send that request back to 192.168.1.112 on port 1351 TCP on this system, and so it's going to send it back to you on that system. Now the same thing is going to work for an HTTP request, except it's going to be on port 443 on TCP. So for example, if you went to chase.com to do some banking, you would do a request to port 443 on TCP, and this server is going to be listening on there, and it's going to know that that's associated with HTTPS, and the data is going to be encrypted, and it's going to send encrypted data back to you on your side. And so that's how this works in a nutshell. Remember, you send a request with an associated port number, and they get that request and they send it back to you to your temporarily assigned port number. So that's ports in action. I know this was high level, and this is a bit of information to grasp. So for those of you that want to get a better understanding of how port communication works on the network, I recommend that you go out to Google, and actually I specifically recommend that you go to YouTube and try to find some videos, because there's going to be a lot of detailed information in there, but that's really beyond the scope of this class. I just want you to understand that port numbers are assigned to different protocols so we can do multitasking on networks, because we have different applications open, we have multiple protocols open, and we only have one IP address and one MAC address. So we need to assign these protocols to specific port numbers. So that's going to go ahead and conclude this lecture. If you have any questions, let me know. If not, thanks for watching, and we'll see you at the next lecture.